Welcome to episode number 6 of Planet Earth. Yes, this is Perkins Girl hosting the podcast series Planet Earth. And if you have missed any of the episodes, I'm saying you, there were 5 episodes before this one, and they were all interesting. Ask the viewers who watched them. So, today's episode is. I actually gave a clue in the last episode about today's episode. If you didn't guess, here we go. Earth's elements. Today's episode is Earth's elements. Matter is composed of elements, substances that cannot be broken down chemically into simpler, more basic substances. To date, 117 elements have been discovered. Some of these, such as oxygen, silicon, aluminium, and iron, are abundant in Earth's makeup. Though it appears that Earth contains a limited number of naturally occurring elements, the number of compounds formed by the joining of one or more of these elements seems nearly limitless, especially when considering both natural and artificial compounds. During the first billion years of the existence of Earth, heat from 3 sources, meteorite impacts, gravity's compression of magma and other material, and the radioactive decay of some elements, caused melting in the interior. Elements separated into layers based on their density. Heavy elements such as iron and nickel concentrated nearer Earth's center. Lighter elements such as oxygen and silicon combine and form surface rocks and minerals. Earth's elements can be displayed in a chart called the periodic table. Periodic table arranges the elements into groups vertically of elements sharing common physical and chemical characteristics, and into periods horizontally based on the atomic configuration of elements. Each element is given a number and distinctive location on the chart. Especially 113, 115, 117 and 118 are reported to have been created experimentally but have not yet received permanent names. Okay, elements essential for life on Earth. When scientists found evidence of simple living cells in rocks they have determined to be 3.5 billion years old, it gave them reason to wonder. How could life have begun on an irradiated oxygen-starved Earth? In their laboratories, they duplicated Earth's primitive atmosphere. To simulate lightning and harsh sunlight, they seared gas mixtures with high voltage sparks and ultraviolet light, forces that make and break chemical bonds. In the resulting view, they found amino acids and the building blocks of life. Now, researchers believe that the same process occurred on Earth 3 to 4 billion years ago. Another experiment showed that amino acids on a hot, dry surface like that of a cooling rock form cell-like spheres when splashed with water. If rain washed the spheres into a tidal pool, a place safe from ultraviolet radiation, more complex molecules could form. At last, one appeared with the ability to reproduce itself. That molecule was similar to deoxyribonucleic acid or DNA, the complex organic molecule that existed in every living cell. And with the appearance of DNA, life on Earth began. What an interesting story, isn't it? I'll just tell you in short what happened again. So, to discover how life have formed on the Earth, scientists have created a simulation in the lab using ultraviolet and voltage sparks. And these forces are used to break and make chemical bonds. In the resulting view, they found amino acids, the building blocks of life. Now, researchers believe the same process occurred on Earth 3 to 4 billion years ago. And another experiment showed that amino acids on a hot, dry surface, when like of a cooling rock from cell-like spheres, when they splash with water, rain washes the spheres into a tidal pool and a place that is safe from ultraviolet radiation because it breaks the chemical bonds. More complex molecules were formed because there were no ultraviolet radiation to break the bond. So more complex molecules have formed in that process. At last, one molecule formed which was able to reproduce itself. That molecule was similar to DNA. DNA is now found in every living cell. So this is how life on Earth have begun. So it's a theory from scientists on how life has formed. Now we are talking about Dmitri Mendeleev, an inventor of periodic table. Born in Siberia, the youngest of 14 children, Dmitry Mendeleev was working as a chemist in St. Petersburg in the early 1860s when he devised a visual scheme by which to organize Earth's elements. At that time, only 63 elements were known, and Mendeleev arranged them in a table by atomic weight, making groupings based on shade properties. He also used his principles to predict the existence of new elements. During his lifetime, 3 new elements were recognized: gallium, scandium, and germanium. They fit his table according to plan. These discoveries went far to validate Mendeleev's periodic table, which has become a fixture in the field of chemistry. Many other scientists have contributed to it since its invention, and it continues to help us understand how our planet and universe are put together. So, Dmitry Mendeleev was a breakthrough in the organizing of elements in the periodic table, and some most common elements you must know by weight in Earth's crust. Oxygen 46.6%, silicon 27.7%, aluminium 8.1%, iron 5%, calcium 3.6%, sodium is 2.8%, potassium is 2.6%. Now all the mentioned elements are in the Earth's crust, okay, not the atmosphere. In the atmosphere, the nitrogen is the highest, but in the Earth's crust, the oxygen, it is 46.6%. So this is about today's podcast topic, Earth's elements, and I would like to conclude it with a fast fact. The periodic table of elements contains placeholders for elements which are not yet officially recognized. And some glossary before we conclude it. Atomic weight. Atomic weight is the ratio of the average mass of a chemical's elements atoms to some standard. Since 1961, the standard unit of atomic mass has been 1. The elements, if arranged according to their atomic weights, exhibit an apparent periodicity of properties. This was a statement given by Dmitry Mendeleev, 1869. And if you're very interested in Earth's elements, I recommend you to go through the 8th grade books of your science, which has enough information to make you curious about what comes next. Thank you. Have a nice day.